So these are methods of differentiation. Okay. So we said the first method is power rule. If you have y is equal to x to the power n, its derivative is going to be n x n minus 1. The second rule is chain rule. Chain rule says if you have y is equal to some function u to the power n, then the derivative is going to be n u n minus 1 multiplied by u prime. Okay, multiplied by u prime. The third one is product rule. If you have y is equal to u multiplied by v, then y prime is equal to u prime v plus v prime u. The fourth one is quotient rule. If I have y is equal to u over v, the derivative is going to be u prime v minus v prime u over v squared. So this is the whole solution 10. Nothing else. Okay, there's no implicit here. We only have this for chain, power, product, and quotient. So when I was saying we did direct, I knew what I was talking about. This is it now. Question 1. We have y. Question 1a. We have y is equal to minus x squared plus 3. So to differentiate, you use power rule. So it will be minus 2x plus 0. The derivative of 3 is 0. To differentiate this to find the second derivative, we differentiate this guy. So we get minus 2. Okay? We are given y is equal to 12 over x minus 4 over x squared plus 1 over x4. So you say, before I bring in y prime, you can rewrite this as 12x power minus 1 minus 4x power minus 2 plus x power minus 4. We haven't differentiated here. Then now we differentiate to find y prime. So we multiply negative 1 by 12, then subtract a 1, it becomes negative 2. Then plus 8x minus 3 minus 4x minus 5. Then you differentiate again. So you have 24x minus 3 minus 24x minus 4 plus 20x minus 6. You can leave your answer even like that. There's no problem. Okay. So that's actually what question 1 has. We can't do more than that. Let's go to question 2. Find y prime in 2 different ways. Okay. Way number 1, by applying the product rule. Way number 2, by multiplying the factors to produce a sum of simpler terms to differentiate. So go to A. A is y is equal to 3 minus x squared, and then x3 minus x plus 1. So number 1, by applying product rule. So say, let u be 3 minus x squared, and v be x power 3 minus x plus 1. Then we differentiate u. We are getting minus 2x. We differentiate v. We are getting 3x squared minus 1. What else are we doing? We now put together. So y prime is u prime v plus v prime u. That is minus 2x multiplied by x3 minus x plus 1 plus 3x squared minus 1 multiplied by u, which is 3 minus x squared. So we are done. We don't simplify much in calculus. 2, by expanding, said by multiplying the factors to produce a sum of simpler terms, we differentiate. So we expand this. So we multiply 3 by x, we get 3x power 3 minus 3x plus 3 minus x power 5 plus x power 3 minus x. So we can put the sums well. So we have 3x3 and x3 there. So we can start with x5 and then plus 4x3 and then minus 4x and then plus 3. Then we do y prime. So we have minus 5x4 plus 4x squared minus 4. So if you were to expand this, it will lead us to that answer. They are the same, except we haven't just expanded. Oh, okay. Sorry about that. I thought I was slow. So I thought I was slow. So here, the first thing, the question says expand. So I was expanding here. So I was multiplying 3 by that. We get 3x power 3. 3 by x, we get 3x. 3 by 1, we get 3. We come back, x squared by x3, and we get x5. X squared by x, we get x3, and then x squared by 1, we get, in fact, it's supposed to be x squared. So we get x squared. And then we come back and put like terms together. So I said the minus x5, I'll write it here. And then the 3x power 3 and the x power 3 add, we get that. Then the minus 3x, that one was x at that point. So we had added, so now we'll add. Okay, so we'll do it nicely. So now we have minus x5 plus 4x3 minus x squared minus 3x plus 3. So how? Now we can differentiate. So there we're just putting them together, then now we differentiate. So we have minus 5x4 plus 4x squared minus 2x minus 3. Yeah. Like that. So this is now the derivative for x5 power rule, for there power rule, power rule, power rule. That is 0. So you see, it's not that complicated. Okay. I hope we are now together.
Sir,
Yes.
so here, when you differentiate 3, oh, okay, all right, I've seen. I thought maybe you've brought back this 3 that is a constant again.
If I check what's coming out of the 0. Okay, so we move to question 3. Question 3, that's question through there. Question through there. So we can start with the same A. Y is equal to 2x plus 5 over 3x minus 2. So you let the numerator to be u and the denominator to be v from the rule. So we just pick the parts. Then you differentiate the u, you get 2. You differentiate v, you get 3. Then you put things together. So you have y prime should be equal to u prime v minus v prime u over v squared. That is, u prime is 2 multiplied by v minus v prime is 3 multiplied by u over v squared. Of course, you can simplify this in the numerator there. You can expand 2 times 3, 6 minus 4 minus 6 minus 15 over this. So we have 0 here. So we get minus 19 over 3x minus 2 squared. Like that. Okay. Part E, that y is equal to root x minus 1 over root x plus 1. So here again, the numerator, we write it as x power half minus 1. The denominator, x power half plus 1. Remember the root, whenever you see a root, you think of power half. And then now you write u prime is equal to half x, then half minus 1 is going to give us minus half. And v prime will also give us half x, and then half minus 1, we get minus half. Or if you want, you can write them. If you want, you can write them values. So you can say, okay, I want to write this guy as 1 over 2 root x, and this guy has the same thing, 1 over 2 root x. As soon as now the halves are negative, then you want to bring them down. And then we do y prime, it will be u prime v minus v prime u over v prime. So u prime is 1 over 2 root x multiplied by v, which is root x plus 1, minus v prime is 1 over 2 root x multiplied by root x minus 1. So you see, over root x plus 1 squared. So we can cancel out when we expand. This piece is going to be positive of this negative, but it is 0. So now they'll just remain, what's happening here? Let's see. This is like root x over 2 root x plus 1 over 2 root x minus root x over 2 root x plus 1 over 2 root x. Yeah, so these will cancel. Okay, and so I'm just going to have this half and that half, they give us one thing. They will be 1 of the 1 over root x. So just have 1 over root x over root x plus 1 squared. So please don't get confused there. Half plus half is 1. So 1 what? 1 over root x. So it comes out like that. Not a big deal there, unless otherwise. So you see, the whole question 3 has only fractions there. So let's go to question 4. Question 4. Suppose that f and g are functions of x that are differentiable at x is equal to 0. That one, at x is 0, they are differentiable. And that f of 0 is 5. F prime of 0 is minus 3. G of 0 is negative 1. And G prime of 0 is positive 2. Can you find the values of the following? A, d dx of f of g. So if you look at that, that's a product rule. Differentiate f of g. That's what the question will say. Which we know that the derivative of f of g is f prime g plus g prime f. Product rule. Now, we want to differentiate that at x is equal to 0, meaning when I find the answer, I substitute, I take 0 in f, I take 0 in g, I take 0 in g, I take 0 in f. So in both f prime and g prime and g and f, I'm taking 0 throughout. But we are given f prime of 0 to be negative 3, g of 0 to be 5, g prime of 0 to be 2, and f of 0 to be 5. So f prime of 0 is that, oh, g of 0 is minus 1, I mean. So here is supposed to be minus 1. So we get 3 plus 10, which is 13. So we haven't even done much. It's just the product rule. Those two things are multiplying. So we get the product. So that's what we have. Okay, so if you check which are, so the other ones we are finding, I think B is saying G dx of F over G. So again, that's question 2. So we have F prime G minus G prime F. Then we divide by G squared. Now we substitute 0. So we have F prime 0, G 0 minus G prime 0, F 0 over G 0 squared. So we get F prime 0 is minus 3, G 0 is minus 1, G prime 0 is 2, F 0 is 5. G 0 is minus 1. Then we square it. So we get 3 minus 10, that's minus 7 over 1, which is minus 7. Okay. C is G over F. So we just use the same question true on that question so that we can do D. So D, you are given D dx. So we have, what is D? 7F minus 2G. So that is, you differentiate this guy. So you differentiate the first one. 7 is the coefficient. Then you differentiate F. After you differentiate, you put 0. Minus 2 is the coefficient. So you differentiate and put 0. You see? So this F is not like X, where when you differentiate, it just remains with 7. No. F is a function like 7. Okay, like let me do this. F is a function like 7x squared. So 7 is always weighting, you differentiate to x. So you see, that's why it becomes 14 when you differentiate. Otherwise, the f is a function. It's not a variable x that will disappear and remain with 7. No. So it will be there. Then now, whatever it is after we differentiate it, we substitute 0 where there's x. So we are given this. So we have 7 by minus 3 minus 2 by minus 1. So we get minus 21 plus 2, which is minus 19, like that. So I repeat D, this 7F we are seeing is 7 times the function. So 7 is just a coefficient. So you differentiate F, you have 7 times the derivative of F minus 2 times the derivative of G. Then in the derivatives of F and G, they are given as values here. So our job, in fact, we want G prime. The G prime is not that guy. It's actually, G prime is 2. So you pick the G prime and substitute there. So we have the 2 here, which is 21 plus 4. So we have minus 21 plus 4, which is equal to minus 17. So there will always be a difference between the derivative of 2f and 2x. So don't take f as a variable. F is a function of x in the question. Okay. Okay, so that was question 4. Let's go to question 5. The time is running out. We can say a thing. Question 5. In the following, let's go back. Oh, okay, so the plus was coming in because we had picked the -1. Okay, sure about that. So the plus was coming in because we had picked the -1. Now we're picking a positive, so it still remains -3. So it will be minus 25. Okay. We now go to 5. In the following, we are given y as f of u. We are also given u as g of x. Find dy dx, which is equal to f prime of g over g prime. Find du dy. Let me check this. I can't see if I find it. How do I find it? We said dy dy. I think there is a problem. It's supposed to be dy du. Is it? I think it's supposed to be dy du. That's how it's supposed to be. But if it's dy du, that formula, let's check. So we're given y to be f of u and u to be g. Okay. So if y if y is equal to 6u minus 6 and u is equal to x4 over 2. And I want to differentiate dy dx. So dy dx should be dy du multiplied by du dx. So since the u that we have is in Since the x is in u, so first differentiate y with respect to u, and then u with respect to x. So we would differentiate y, which is 6u minus 6. We differentiate it, we get 6. And then differentiate u, we get 4x3 over 2, which is equal to 2x power 3. So you differentiate them separately, then you come here and multiply them. So we have 6 multiplied by 2x power 3. So that we get 12x power 3. Like that. So anyway, this is a chain rule. And mostly if we define them separate like this, it becomes a bit tricky for us to just hit direct. Because look, that u, when we differentiate it, it's supposed to be 6u u prime. Yeah, so it's like du u prime. So the u prime is this one. So the same chain rule, now we are seeing it being used in the deep concept of it. So tomorrow we will have, our class will start with finishing this tutorial sheet, and then that will be the first session. The second session, if we would have finished, then we can do other things that are in other tutorial sheets. Okay, and then the other day we'll just open up and do things in the test. Of course, our eyes are on, we want to see now the relationship between the test one that we wrote and the test one for last year. Are they related anywhere? If they are, then what is our projections for test two for this year? Or where do we find the relationship? There's always a relationship somewhere. That's what now we're going to look at after tomorrow. So look at the relationship and see where it comes from, and then hit where it's coming from in preparation for our test on Sunday. So we can end here.